All right, today our objective is to define and calculate sine and cosine functions within the context of the unit circle. So there's a lot of words on here that we probably haven't seen before, have only seen a few times. Sine and cosine is something you definitely hit in math too, dealing with SOHCAHTOA. This unit circle, though, is completely brand new, or likely is brand new for you. So um, throughout today's notes and activities, if you're making this up, you should absolutely pull up this tool from GeoGebra. You can either hit this QR code or type in this link, or at the very least, it is linked on Canvas to help you out with your notes. And if you go to that link, you're going to see this kind of interactive screen here. And the main thing we're going to do is we're going to play with this blue cursor. If we click and slide it back and forth, we're going to get a line that rotates around our circle and tells us a bunch of values. And this is going to be the main tool we use today in our class. So before we do any exploration or playing around, we do want to define a few things. So the first thing is probably that new word, the unit circle. And this is just going to be a circle of radius 1, and it's going to be centered at the origin. If you look at your note sheet here, you can see that this is kind of what's portrayed here. Centered at the origin, we have our x-axis, our y-axis, and we have a circle surrounding it. Then along this unit circle, the cosine function, it's going to describe the width of a triangle. And I'll show you kind of how we build that triangle in a little bit here. And the sine function is going to be the height of that triangle. The way to remember this is the words co-height and height. Co-height is cosine, sine is height. So that co and co go together. So let's kind of build this out to see what we're talking about here. So we have our unit circle. And if we drew a line on our unit circle, let's say from our origin to here, and you should be doing this on your notes here. And we say, all right, that has a length of 1 because our unit circle has a radius of 1. Now, if we were to draw a line from this point here straight down onto our x-axis so that we make a right angle, we would get a right triangle here. And I'm going to draw that straight line down in blue, and I'm going to draw this horizontal line across in green. You might need to kind of make that pop a little more. But this green horizontal line that I just drew, this is our cosine. Okay, the width of the triangle, the co-height of that triangle, that is going to be the cosine of theta. And theta is whatever angle we rotated off the line here. Then our blue line, the height of this triangle here, that is going to be our sine function. So if we kind of click to this GeoGebra tool over here, you'll see the same image kind of shows up. We have from our origin, we have a line of 1, this black line here. We have a blue line coming down, that's our sine value. And our green line coming here, that's our cosine value, that's the width. As I rotate this by moving my blue slider, our triangle shape changes, right? And it kind of flips and mirrors as we move along around our circle until we get back to 0 or 360. So we notice here we have a very short and wide triangle. As we get close to 90 degrees, we have a very tall, skinny triangle. And that kind of repeats throughout our circle. Some key features. If we define our cosine as x and our sine as y, which it should be on our unit circle, you'll notice that both of these are positive in this top right corner here. So if I'm looking at my quadrant 1 over here, both my sine and cosine are positive. As I move to the second quadrant, okay, so in this quadrant here, my cosine value, that's now moved across my y-axis, so it's negative. And check it out, up here we do have a negative cosine and a positive sine. If I continue rotating it into this third quadrant, then you will notice that we're both left of our y-axis and below our x-axis, so both of these cosine and sine values are negative. And lastly, if we move into that fourth quadrant, and in this fourth quadrant, we have a positive cosine because we're on the right side of our circle, and a negative sign because we're below that x-axis. So if we go back to our notes, let's quickly summarize that stuff here for quadrant 1, 2, 3, and 4. These different labels are thrown around your graph, but just I was not able to match that kind of formatting, so make sure you list those out on the front page of your notes. So what we want to do next is kind of an exploration activity to build out what this unit circle looks like so we get a good understanding of what's happening. So we're going to go around and literally every kind of key point on here, this 30 degrees, this 45 degrees, this 60, etc., 120, 135, we're going to define cosine and sine. And these are the x and y values that come from GeoGebra. So if I go over to GeoGebra for my 30 degrees, what I'm going to do is I'm going to move this slider. I'm going to slide it to 30 degrees. And you'll notice that we have our cosine and sine value right here. And they actually correspond to our x and y coordinate right here as well. Notice how cosine is x, sine is y. So we're going to take those numbers, and that is what we are going to kind of write into our little unit circle that we're building out. So we had an x value of 0.87 and a y value of 0.5. Okay, then we kind of move on to the 45 degrees. So I'm going to slide my angle to 45 degrees. You might need to use the arrows on your keyboard to jump one at a time. And here we notice that we have cosine of 0.71, sine of 0.71, and that's listed as the x and y coordinate as well. So I'm going to go back in, I'm going to type that in or write that into my notes, 0.71, comma, 0.71. And you're going to kind of continue repeating this for all of these points around our circle. So 60 degrees, 120, 135, 150, 180, 210, 225, 240, 300, 315, and 330. You should have a complete unit circle. Now I'm going to show you a completed one so you can get all these values yourself. But it really helps to get an understanding of the unit circle if you go do this yourself one by one using the GeoGebra tool. So you can see how that triangle changes and see those repeated values. So now that you've had a chance to do it, just quick double check, make sure that all of your values line up with what we have kind of listed over here. Notice how I have the negatives and positives are spelled out. This is really important and kind of lines up with some of the notes that we took earlier in the different quadrants. So we can then use this circle to evaluate our sine and cosine function simply by going to the angle and then either pulling the x value for cosine, that's our side to side, or our y value for sine. So if I want to calculate cosine of 60, I move to this line over here on my unit circle. This is my 60-degree line. And I pull that x value, which is my cosine of 0.5. So my cosine at 60 degrees is 0.5. Okay, if we want to do this for sine, I'm going to throw this one in green. We're asking for 120, so I'm going to move to my 120 degrees. Okay, and I'm pulling the y value because that's my sine value, and I get 0.87. And lastly, I'll do in purple, we have sine of 240, so I'm moving to 240 degrees. And we're pulling our y value because we're pulling sine, that's our triangle height, and that is negative 0.87. Now, we've built up a good understanding of what happens on the unit circle and where these sine and cosine values come from. But fortunately, we have all of these things programmed into Desmos. And if you think about it, we didn't track all of our angles, right? if I asked you to find, let's say, the sine of, I don't know, 97, that doesn't show up here, right? But we would expect it to be somewhere about here. It doesn't show up as one of the key angles in our unit circle, but we do know it exists. So we can either go to GeoGebra to calculate it if we wanted to, and move to 97 and come up with our sine of 97 is 0.99. Or even better, we can go to our NC test version of Desmos, and that has all of our sine and cosine values plugged in. And so let's see here. If we go in and we do the sine of 97, boom, that matches what we have, what we calculated with our GeoGebra tool, that 0.99. So um, one thing to note before we go ahead through example 4, 5, and 6 and get into practice is that the settings need to be correct. That's important. Tomorrow we're going to learn about 2 different ways to measure angles. Today we're working in degrees, so we need to make sure that our Desmos setting is in degrees. If we click this wrench in the top right corner, notice how this box here down on the bottom is listed in degrees. If I change that to radians, notice how the value that I plugged in for sine 97 changes. We always want to make sure that we're using the correct units. Today we're going to work in degrees. Tomorrow we'll introduce the concept of radians, but it's important to get the right value. So I have my setting correct. I can clear this out. And if I want to find the cosine of 230, all I have to do is type in the cosine of 230. Let's go into Desmos, cosine, parentheses 230. And you'll note that we don't really need our degree symbol here. And let's check this out with our GeoGebra just to double check it. If I go to 230 degrees, move my cursor just a little bit, it makes sense that we get a cosine value of negative because my triangle is on the left side of the graph. We get negative 0.64, and that matches what we get in our calculator. So I can write that in negative 0.64. We're going to round to 2 decimals today. Okay, I can repeat the same thing for sine of 75. Okay, it looks like I should have 0.97. Let's write that in as our answer. Equals 0.97. And I'm going to check that out, see if it makes sense based on my unit circle. I go to 75 degrees. It looks like I have a really tall triangle that's really close to 1 in my height, so 0.97 also matches up, and that makes sense. So lastly, this cosine of negative 130. So I'm just going to type in cosine of negative 130. And that gives me negative 0.64. Let's check this out. If I plug in 130, negative 130, well, actually, we can't really do that in our GeoGebra tool. So we're kind of relying on our Desmos. So cosine of negative 130 is going to be that negative 0.64, similar to our answer in example 4.